So we have seen about properties of photon. Photon is a wave packet, and frequency of photon is frequency of wave in that wave packet, and intensity of photon is a result of superposition of two or more photons. So when you add two or more photons, you will get a high intensity photon. Right? So here if A is the amplitude, this will become 2A. So I is so I increases by 4 times. If amplitude doubles, intensity rises by 4 times. Okay. So now when a group of photons add up, we will get a wave in time frame. So here the photons are superimposing, which are released at the same time. So actually this is a graph between time versus amplitude. So on x-axis you have time. So if two or more photons release at the same time, we get a high amplitude photon or a high intensity photon. But if they release at different times, one after the another, then what happens? So we get a series of wave patterns, a series of wave packets. So there will be some disconnection. Right? There will be some disconnection between these photons. So now I'm defining, so to get this construct interference, we need waves mixing in same phase. So let's say if I take two wave trains which have different phases, let's say this is like this, and next wave also starts like this. Then at some point you may have constructive interference, and another point you have destructive interference. Right? So the superposition may not remain same as a function of time. So as time progresses, at some time you may have constructive interference, at some time you may have destructive interference. So things vary with time. So now I'm going to define, so this interference is superposition of waves, either constructive or destructive. So I'm defining coherence. Coherence means, check for it, define coherence. Google it, children. So coherence అంటే ఏంటంటే to be consistent. Consistency అంటే invariant. With time. టైంతో పాటు మారకుండా ఉండేదాన్ని కన్సిస్టెన్సీ అంటున్నాం. అది కూడా చూడండి, ఒకసారి కన్ఫర్మ్ చేయండి. డిఫైన్ కన్సిస్టెంట్ అంటే ఏంటి? ఓకే. సో ఇన్వేరియంట్ విత్ టైం, టైంతో పాటు మారకుండా ఉంటే దాన్ని కన్సిస్టెన్స్ కోహరెంట్ అంటున్నారు. ఇంకొక చోట అక్కడ కూడా వాడతారే ఈ కోహరెంట్ కన్సిస్టెన్స్ అనే మాట. కుకింగ్లో ఎక్కడైనా వాడతారా? సేమ్ కన్సిస్టెన్సీ. కన్సిస్టెన్సీ అంటే ఏంటండి? సపోజ్ సాల్ట్ లేదా బ్యాటర్ ఏదో మిక్స్ చేస్తున్నారు, సేమ్ కన్సిస్టెన్సీ అంటే ఏంటి? ద మిక్సింగ్ షుడ్ రిమైన్ యూనిఫామ్ త్రూ అవుట్ ద మెటీరియల్. సో అంటే ఒక చోట ఎక్కువ ఒక చోట తక్కువ లేదా కలర్ ఏదో మిక్స్ చేస్తున్నారు, షుడ్ బి యూనిఫామ్లీ స్ప్రెడ్ ఓవర్ ద ఎంటైర్ మెటీరియల్. సో అక్కడ వచ్చేసి ఎంటైర్ మెటీరియల్ స్పేస్ మొత్తాన్ని యూనిఫామ్గా కవర్ చేయడం. ఇక్కడ జనరల్ మీనింగ్ ఏంటంటే విత్ టైం. కన్సిస్టెన్సీ అంటే రిమైన్ సేమ్ ఓవర్ టైం, ఓవర్ అ పీరియడ్ ఆఫ్ టైం. సో ఇప్పుడు కోహరెన్స్ అంటే ఏంటి? ద వేవ్ ప్యాటర్న్ షుడ్ రిమైన్ సేమ్ ఓవర్ అ టైం. ఓకే, సో మనకి ఏంటి ఇక్కడ ఆఫ్టర్ సర్టెన్ టైం దాటి ఈ ఒక ప్యాకెట్ దాటిన తర్వాత ఏమవుతుందంటే ప్యాటర్న్ ఇస్ చేంజ్. సో ద ఫ్రీక్వెన్సీ రిమైన్ సేమ్, ద వేవ్ ప్యాటర్న్ ఇస్ చేంజ్. సో ఇక్కడ నేనేం డిఫైన్ చేస్తాను? కోహరెన్స్ టైం. Time over which two wave trains maintain same phase. టూ వేవ్ ట్రైన్స్ సేమ్ ఫేజ్ మెయింటైన్ అవుతున్నటువంటి టైం ఎంతసేపు అవి సేమ్ ఫేజ్లో మెయింటైన్ అవుతున్నాయి అని చెప్పేది. సో మనము టైంని వేరియబుల్గా తీసుకున్నాం కాబట్టి ఇన్ జనరల్ ఇట్ ఈస్ సజెస్టెడ్ టు కీప్ ద స్పేస్ కాన్స్టెంట్. సో మనం స్పేస్లో ఒక పాయింట్ దగ్గర అక్కడ కూర్చుంటాము, ఇక్కడ రెండింటికి ఒకటే ఫేజ్ ఉంది, లేదు ఒక ఫేజ్ డిఫరెన్స్ ఈజ్ ఆల్సో మీనింగ్. సో ఇక్కడ ఫేజ్ డిఫరెన్స్ 0 ఉంది. మేబీ ఇంకొక వేరే ట్రైన్ తీసుకున్నట్లయితే ఇట్ మే హ్యావ్ ఆపోజిట్ ఫేజ్, స్టిల్ ద ప్యాటర్న్ రిమైన్స్ సేమ్ ఫర్ ఎ పీరియడ్ ఆఫ్ టైం. సో మన స్పేస్లో ఒక చోట ఎక్కడ ఫిక్స్డ్గా కూర్చొని ఉంటాం, టైమ్ పాస్ అవుతున్న కొద్దీ వేవ్స్ అన్ని ఇట్లా ట్రావెల్ చేస్తున్నాం. ఫర్ ద టైమింగ్ దట్ ట్రావెలింగ్ ఇన్ దిస్ డైరెక్షన్. ఆఫ్టర్ సర్టన్ టైం దిస్ పాయింట్ విల్ కమ్ అండర్ అబ్జర్వేషన్. స్టోరీ రివర్స్ అయిపోయిందా? Okay, after certain time this point will come under observation. So here also the phase difference is 0. Here also the phase difference is 180 degrees. So, and on x-axis I am taking time, right? So as time progresses, the phase difference at a particular point in space over a period of time does not change. So phase difference between two points or two wave trends in space remains same over a period of time. So the time duration is called coherence time. This is called tau. So once I define coherence time, I can also define coherence length. So if this velocity of light or electromagnetic radiation is constant in a given medium, So I can define coherence length also. Coherence length is so I call it as delta L. It is c times tau. C is velocity of light. This is coherence time. The study of waves can be carried out in two ways, one as a function of time, another as a function of space. So, whatever variations that occur in time will reflect in space. So, the study of waves, I mean, this you might have seen already, but repeating it again. So, the study of waves can be carried out in two ways. So, what is a wave, by the way? Wave. Wave is a periodic disturbance. The disturbance is getting repeated again and again over a time. Wave is a periodic disturbance. That carries energy. Without actual displacement of particles involved. So particles అనేవి they may at most execute to and fro motion. Let's say ఒక స్ట్రింగ్ రోప్ ఏదో తీసుకున్నారు and to and fro motion జనరేట్ చేశారు. It generates it. Okay. So ఇక్కడ ఏమవుతుందంటే ఒరిజినల్ పొజిషన్ నుంచి the rope is moving up and down from original position. But ultimately average displacement is 0. So after a certain time it will go upwards and this portion will come downwards. So overall average displacement is 0 over a time. So ఏమవుతుంది? It is a periodic disturbance. It carries energy from one end to other end and net displacement is 0. A particles అనేవి they are not displacing permanently. ఓకే, సో ఇలాంటి దాన్ని వేవ్ అన్నారు. మరి దాన్ని ఎట్లా స్టడీ చేయాలి? హౌ టు స్టడీ దట్ వేవ్? సో అల్టిమేట్లీ స్టడీ ఆఫ్ వేవ్ ఇంప్లైస్ స్టడీ ఆఫ్ ద డిస్ప్లేస్మెంట్ ఫ్రమ్ మీన్ పొజిషన్, రైట్? సో ఒరిజినల్గా ఇలా ఉంది, ఇది డిస్ప్లేస్ అయింది. ద యాక్ట్ ఆఫ్ జనరేషన్ ఆఫ్ వేవ్ ఈజ్ ఈక్వల్ టు a displacement from mean position. So study of wave means study of displacement from mean position. The same rule applies even for longitudinal waves. Let's say you have a bunch of air films. So when you apply some force, when you start speaking, what happens? They'll move forward and backward. So you'll get compressions and rare fractions. This is compression, rare fraction. So here also you will see a displacement from mean position. So both for longitudinal waves and transverse waves, the generation of wave implies a displacement from mean position. So now we have to study the displacement in order to study the wave. So how to study the displacement? So I have two possibilities as a function of space. So fix the time or freeze the time and see how the displacement varies as a function of time. Sorry, as a function of space. So I keep t constant and collect the data of displacement as a function of space. I get a graph. This is a graph. This is our original situation. This is a graph as a function of space at a particular time. So how to freeze time? Time net lo fix chesalante. At a particular time, we have to measure the displacement at various locations in space. Simple option is take a snapshot. Photo తీయండి. Time freezes. So information at a particular time is recorded on the photograph. Then measure the displacement. Collect the data. Plot a graph. Another way is you keep the space constant and collect the data as a function of time. So we sit at a particular location and observe the displacement as a function of time at 1 second, 2 seconds, 3 seconds, 10 seconds, how the displacement varies. At sometimes it goes up, sometimes it goes down. So as a function of time, you gather the data and if you plot a graph, you get a graph. So here I define wavelength and here I define frequency. So once I complete my study, I have to define some standard parameters. So here I am defining wavelength, the length of a single wave in space domain study, and here I am defining number of waves in 1 second as frequency. Okay, so these are the two different studies for a same system, and they should represent the same story, right? So they should be connected. So the connecting parameter is the equation is this. There should be some equation connecting these two studies. The variation of displacement as a function of time and as a function of space. So రెండింటిని కనెక్ట్ చేసే ఒక ఈక్వేషన్ మనకు కావాలి. So then what is this parameter? So here on one end you have variation of displacement as a function of time, other end as a function of space. So రెండింటిని కనెక్ట్ చేయాలి. ఎట్లా కనెక్ట్ చేయాలి? సో డైమెన్షనల్ ఫార్ములా చెక్ చేస్తే అక్కడ మధ్యలో ఏమొస్తుందని చూడాలి. ఏమొస్తుందండి? సో హియర్ ఇట్ ఈస్ L/T². This is L/L². Now what about that? బ్యాలెన్స్ చేస్తే ఏమవుతుందండి? ఇంకా L²/T². So call it as velocity square. So the wave equation is dou square by dou t square is equal to v square dou square by dou t square. So velocity is the parameter that connects the study of wave as a function of time and as a function of space. So here on one side you have variations with respect to time, on the other side you have variation with respect to space. So ఇది మనం టైం ఎంత మార్చినా కానీ ఇక్కడ స్పేస్ అనేది మారదు, ఇక్కడ స్పేస్ ఎంత మార్చినా ఇతర పక్క ఇక్కడ టైం అనేది మారదు. సో అంటే ఏంటంటే దిస్ మస్ట్ రిమైన్ కాన్స్టెంట్. The connecting parameter should remain constant. I mean both sides should be equal to a constant. Otherwise we cannot fix them. Right? Here time is variable, here space is variable. Both are varying independently. So if I vary time, space is not varying, and if I vary space, time is not varying. So both must be equal to a constant. So that velocity is a constant. Then how to obtain that constant? It is obtained by multiplying the constant parameters defined in each domain. So V is obtained by mu is what? Frequency, number of waves in 1 second. So it is number of waves by total time. So I count number of waves for 10 seconds and divide it with 10. I'll get frequency. So number of waves by total time, and wavelength is length of single wave. So on the denominator you get total length by number of waves. So to get the wavelength you have to calculate the length of single wave. So calculate total length of 10 or 15 waves and divide it with number of waves. You get length of single wave. Same time you need to get the number of waves in 1 second. So you count the number of waves for 10 seconds and divide it with 10, whatever time. So you get velocity. Total length by total time is velocity. So velocity of light remains constant as long as it travels in a same medium. So what is the implication of that? What is the consequence of that? What happens if velocity remains same? For all colors, velocity is same. So we have blue at 3000 or 4000 angstroms, green at 5000, yellow at 6000, red at 7000. So we have visible light spectrum from 3000 to 7000 angstroms. So as the wavelength increases, velocity should remain constant. So how is it possible? The wavelength is increasing, velocity should remain constant. The frequency should decrease. So as the wavelength increases, frequency decreases to keep the velocity constant. Velocity constant ఎందుకు ఉండాలి? To keep the studies in space domain and time domain connected. Space domain లో వేరియేషన్స్, టైం డొమైన్ లో వేరియేషన్స్ కనెక్టెడ్గా ఉండాలంటే వెలాసిటీ కాన్స్టెంట్ ఉండాలి. వెలాసిటీ కాన్స్టెంట్ ఉంటే వేవ్ లెంత్ పెరుగుతున్న కొద్దీ ఫ్రీక్వెన్సీ తగ్గిపోతుంది. సో ఇదే మనం జనరల్గా you can observe this even in this case. So if you raise the frequency, if you raise the number of oscillations per second, you get shorter waves. If you reduce the frequency, so if you wave the string slowly, if the frequency is low, you get longer waves. Right? So that is why that is the first wonder of nature, I should say, because you can see all the colors at the same time. If different colors have different velocities, what happens? Suppose some person is walking towards us, we'll see a blue color image first, then a green color image, then a red color image. So we say a 3D film without goggles. Right? That is not happening because all colors are traveling with same velocity. We are able to see a mixture of colors just because of this fact. That's why I should say it is a first wonder of nature. All colors travel with same velocity. So this also has a breaking point. We'll see that. So now, what happens if the light enters into a different medium? So here velocity is constant. Now the light enters from one medium to another medium. So here the velocity is v1, velocity is v2. I call it as, let's say this is rarer medium and this is denser medium. What happens? This v1 is greater than v2. Light gets slows down when it enters a denser medium because it interacts with more and more atoms or molecules. So it slows down. Then now comes the question, velocity is reducing. Let's say this number 3 becomes 2 or 1.5, let's say. The velocity becomes half. Now which one should I reduce? Frequency or wavelength? Or both?
Constant sound.
ఈ వెలాసిటీని తగ్గించాలి. ఐ టు మేక్ దిస్ హాఫ్. స్క్రీన్ నేర్ 1.5 చేయాలి. దీన్ని తగ్గించాలా, దీన్ని తగ్గించాలా, లేదా రెండింటిని తగ్గించాలి. సో వెలాసిటీ డిపెండ్స్ ఆన్ బోత్ ఫ్రీక్వెన్సీ అండ్ వేవ్ లెంత్. సో ఐ హ్యావ్ 3 చాయిసెస్. Either I have to fix the wavelength and reduce the frequency, or fix the frequency and reduce the wavelength, or reduce both. Which choice should I take? So the simple justice is reduce both of them equally. But there comes a small problem. So what happens if I reduce the frequency or vary the frequency? So here on one side the light has higher frequency, on the other side frequency becomes half. Let's say I'm reducing frequency. What happens? So on the one end I have 10 oscillations per second, on the other end I have 5 oscillations per second. What happens at the boundary? So here the wave is oscillating 10 times per second. Here it is oscillating only for 5 times. So by the time this reaches the other end, on the top portion the wave reaches one end and comes back. What happens? Wave gets disconnected. Wave gets disconnected. We won't see the wave from one end to other end. So to keep the wave connected across the boundary, the frequency must remain constant. Frequency must remain constant. So whatever that first wonder of nature is broken on the next level itself. So the frequency remains constant instead of velocity. So that leads to second wonder of nature. We'll see that. So now, defining refractive index, the index of refraction, the amount by which the wave gets refracted or gets bent, as the ratio of velocity in first medium to velocity in second medium. What happens to this? Nu remains constant. Nu lambda 1 by nu lambda 2, or it is lambda 1 by lambda 2. So what is the wavelength of sodium light in water, let's say? Sodium light wavelength is 5893 angstroms in air or vacuum. What is its wavelength in water? For water, mu is 4 pi, 1.3. So what is lambda 2? Do it in your notes. So it is 4420. So light with wavelength 5893 angstroms in air or vacuum looks yellow in color. The same light, when it travels in water, it will have wavelength of 4420 angstroms. That means what? The light with 4420 angstroms wavelength is yellow in color in water. So now, how to fix the color? Red is 7000 angstroms, blue is 4000 angstroms, green is 5000 angstroms అని చెప్పేస్తున్నాం. But it is varying, right? Now yellow is at 4000 angstroms in water. So if you want to mention the color of a light by its wavelength, you have to mention the medium also. In which medium it is traveling. So red has 7000 angstroms wavelength in air or vacuum. Green has 5500 angstroms in air or vacuum. So if you check the frequency is what? Velocity by wavelength. That remains constant. Let's say if you take yellow color, what is its frequency? Frequency of yellow light. Calculate C by lambda. So here the velocity of light in water is what? 2.2. 2.8. 2.5. Okay. So velocity of light reduces, and at the same time wavelength also reduces when the light enters into water. And ultimately velocity by wavelength, that frequency remains constant. For sodium yellow, the frequency is 509 terahertz. Okay, so this frequency is 509 terahertz for sodium yellow. So that is the situation. So whatever may be the velocity or variations in wavelength with respect to medium, frequency remains constant. So okay, it is more standard to present the color of light in terms of its frequency. And that is what we do even in quantum mechanics. We represent the energy in terms of its frequency. The light is characterized by its frequency. The photon is defined by its frequency. Okay. So wavelength is material dependent. It varies with material and material. Okay. So if you wish to specify the color of a light by its wavelength, you have to specify the medium also. So sodium has 5893 angstroms, sodium yellow, in air or vacuum. Okay. So now comes the another observation. So this is refractive index. So if I increase the wavelength, so more is the wavelength, more is the, so this is sin A by sin R, right? So if I increase the wavelength, R also increases. The second way. If I increase the wavelength, R increases. So what happens? Red has more angle of refraction than blue. More the wavelength, more is the angle of refraction. And less is the refractive index. So various colors have various refractive indices. You see clearly, different colors travel with different wavelengths, different velocities, and they get different angles of refraction and different refractive index. Color మారుతున్న కొద్దీ వేవ్ మారుతుంది, వెలాసిటీ మారుతుంది, యాంగిల్ ఆఫ్ రిఫ్రాక్షన్ మారుతుంది, రిఫ్రాక్టివ్ ఇండెక్స్ మారుతుంది. సో యూ సీ డిఫరెంట్ కలర్స్ ఇన్ డిఫరెంట్ డైరెక్షన్స్. So that is the second wonder of nature. So once you break this rule, the first wonder of nature, velocity remains constant. If this rule breaks, we see a rainbow. So different colors travel in different directions with different velocities. So ultimately something else remains constant. Here I am sending the larger wavelength waves in longer paths and shorter wavelength waves in shorter paths, so that everybody will come out at the same time. So here if I have 3 waves in a longer path with longer wavelength, in a shorter path I will have 3 waves in that shorter path, so that all colors will come out of the medium at the same time. So the number of waves remains constant during refraction. Wave number remains constant and frequency remains constant. So if red has a longer wavelength and we have 1.5 wave here, blue also will have say 1.5. So longer wavelength wave take longer path, shorter wavelength waves take shorter path. So ultimately everybody will come out at the same time. So what is observation here? So then what is refractive index, by the way? The meaning ఏంటి? More the wavelength, so lambda r is greater than lambda blue. Wavelength red కి ఎక్కువ ఉంది, angle of refraction is greater than R3 and mu R is less than mu A. Refractive index for red is less than that for blue. So about refractive index and what is that? Indexing. It is index of refraction. It is an indicator of refraction. Red has less refractive index. Blue has more refractive index. అంటే red refracts more than what? Blue refracts more than red. So if you see the original direction of incidence, red bends less than blue. Red refracts less than blue. Red bends less than blue. So refractive index is an indicator of bending of light. More the refractive index, more is the bending, more is the deviation from original direction. So ఇప్పుడు చెప్పండి. Now tell me this. The refractive index of what is 1.33 అంటున్నా. అవునా? మరి ఇక్కడ మనకు వచ్చిన కన్క్లూజన్ ఏంటి? Red has a lower refractive index, blue has a higher refractive index, green has moderate refractive index. So different colors have different refractive indices. Then refractive index of water is defined for what color? ఒక్కొక్క కలర్కి ఒక రిఫ్రాక్టివ్ ఇండెక్స్ ఉంటే ఏ కలర్కి చెప్పారు 1.33 అని? డౌట్ రావాలి కదా. సో పాసిబుల్ ఆన్సర్ యావరేజ్ ఆఫ్ ఆల్ కలర్స్ అనుకోవడానికి ఒక పాసిబిలిటీ అంటే 3000 7000 యావరేజ్ 5000 యాక్షన్స్ గ్రీన్ కలర్ అవడానికి పాసిబిలిటీ ఉంది. బట్ ద రిఫ్రాక్టివ్ ఇండెక్స్ ఇస్ డిఫైన్డ్ ఫర్ yellow కలర్, sodium yellow, because that was the only monochromatic source available at that time. సో మనం ఒక మోనోక్రోమాటిక్ సోర్స్ తీసుకుంటే అది ఎంత బెండ్ అవుతుందో చూస్తే సింగిల్ కలర్. సో sodium yellow was the only monochromatic light source available at that time of defining refractive index. So refractive index is defined for sodium yellow. It is not the average of colors. It is sodium yellow. So refractive index of material is defined for 5893 angstroms in error vacuum compared to error vacuum. Okay, so 5893 angstroms ఉన్నది మెటీరియల్లోకి వెళ్తే ఎంత అవుతుంది అనే దాన్ని బట్టి refractive index డిఫైన్ చేశారు. So all other colors have different numbers, but refractive index of material is defined for sodium yellow. So ఈ లెక్కన మనకి ఏదైతే 2010 జామ్ పేపర్ CU set paper, the question was wrong. The given refractive index of water is 1.3 thresholds and wavelength of light in air is so and so, some 5500. What happens to its wavelength in water? That was the question. So refractive index of water is 1.33. Green color wavelength is 5500 angstroms. What happens to its wavelength in water? Was the question. So we have to use this. Mu is lambda 1 by lambda 2. Lambda 1 is 5500. But mu is 1.33 only for sodium yellow. For green, you will have a different number. You can't, you should not. The question was wrong. So అది యాక్చువల్గా మన ఎవరు కాన్సెప్ట్స్ ఆఫ్ ఫిజిక్స్ ఎస్సీ వర్మ బుక్లో ఉంటుంది అది. సోడియం ఎల్లోకైనా ఇచ్చిన ప్రాబ్లం అది. Sodium yellow light is traveling into water. What happens to its wavelength? This is the problem. It turns out to be 4400 around. 4400 ఇంకా తక్కువ చిన్న డౌట్. So the question available in H.C. Verma Concepts of Physics was for sodium yellow. I mean, they have extended the same question to green color, but we cannot have the same refractive index for green. So that is a small flaw in that question. Okay, so that is the story of refractive index. So this is a first rule of optics, first wonder of optics. Velocity remains same as long as the light travels in same medium, and if it enters a different medium, frequency remains constant. So now come back to this coherence. So to have constructive interference or destructive interference, we should maintain a constant phase throughout a span of time or in space. So once I define coherence time, the time for which the two wave trains remain in same phase is coherence time. So the same reflects in space also, because both are two different studies. Space domain study is different from time domain study, but both are connected. So once you fix the time in space, it also fixes the space. So once you have a fixed value of coherence time, you have fixed coherence length. Okay, the same effect reflects in space also. So here on x-axis you have x. Here on x-axis you have time. So the same waves you will be studying in space domain here. Okay. So coherence length and coherence time. So all this is called temporal coherence. Time dependent coherence, temporal. A coherence that is related to time is called temporal coherence. So here T is constant, then what happens to its frequency? Minus 1 by lambda square into delta lambda. Okay, sorry. Change in frequency ఏమవుతుంది? One by delta T, right? 1 by tau. Coherence time over which so here the time period or time remains constant. When time period remains constant, it is invariant. There is no change in time period. So corresponding change in frequency is also 0. So for the light to have temporal coherence, change in frequency should be 0. So all monochromatic light sources are temporally coherent. So అంటే ఏంటంటే yes. So if we wish to have infinite coherence time, then the change in frequency will be 0. If this is infinity, this becomes 0. So all monochromatic light sources are temporally coherent. So for monochromatic light sources, the waves are well connected, wave packets are well connected. The only condition is that frequency should remain constant. Delta nu must be 0. In that case, all wave packets are well connected, perfectly connected. So if the one wave packet ends here, next wave starts from that point. But sodium yellow has a bandwidth of 6 angstroms. Actual sodium yellow wavelengths are what? 5890 and 5896 angstroms. That is a 6 angstroms bandwidth for sodium yellow. So corresponding bandwidth and frequency, what is delta nu for sodium yellow? It is C by lambda 1, C by lambda 2 difference. Delta nu for sodium yellow is what? C by 5890, C by 5896 difference.